So in this video, I'm going to continue the remaining part of the KCET questions, uh, which is in 2024 paper. So this question number 26. The Zeeman pattern of lines consists of 6 equidistant components. The upper state term is 2p3 by 2. What is the lower state term? So it is 2p1 by 2. Because for J, always it is L plus 1 by 2 to L minus 1 by 2. So therefore, L plus 1 by 2 they are given, that is P3 by 2, and L minus 1 by 2 is 1 by 2. So 2p3 by 2, answer is option A. Next, in a two-level atom with energy difference of 1 electron volt, the upper level is populated by twice the number of atoms than that of in the lower level. What is the temperature estimated from Boltzmann factor? So we know that expression for this, that is N2 by N0 is equal to e power minus E2 minus E1 divided by KT. So N2 by N1, N2 we know they are mentioned that clearly twice the lower state. The two level atom in energy difference is 1 electron volt. The upper level is populated twice the number of atoms than in the lower level. Here N0 is lower level and N2 is upper level. So 2 into N0 divided by N0, which is equal to e power minus. So the energy difference they mentioned that 1 electron volt. So e power 1 divided by KT. Okay. So then if you take a ln on both sides, it will becomes ln N0 cancel, ln 2 is equal to minus 1 by KT. Therefore, KT is equal to minus ln 2 and T is equal to minus 1 by ln 2 divided by into K. Okay, so therefore T is equal to, if you substitute the value of K and ln 2, so that is 1 by ln 2 is 0.693, and if you substitute the value of K and 8.16 into 10 to the power of minus 5, you will get T is equal to 16 point. So T is equal to 16.7 into 10 to the power of 3 Kelvin. So option B is correct. Next, so the question 27th, the ESR spectrum of an unpaired electron interacting with two equivalent protons shows 3 lines. What is the ratio of the intensities? Option C is correct, 1:2:1. Next, an NMR signal for a compound is found to be 180 Hz downward from TMS peak using a spectrometer operating at 60 MHz. What is the chemical shift? So it is very easy question. So we know that the chemical shift is also equal to F2 by F1 into 10 to the power of 6 if you convert into ppm. So which is equal to frequency F2, they are given that 180 Hz and F1 is 60 megahertz. So 60 into 10 to the power of 6 into 10 to the power of 6, 10 power 6 cancel, 0 cancel, and remaining is 6 3s are 18. So 3 ppm. So option D is correct. And this is question number 29. The density of 100 planes in a simple cubic lattice with A is equal to 2.5 Armstrong is. So these are the given options. In this option A is correct. How? Because we know the density of a plane is equal to number of atoms in a unit cell divided by A square. So number of atoms in a unit cell of what? Simple cubic. So therefore number of atoms in a simple cubic is 1 divided by A square. They are given the value of A. Okay, A value they are given that A is equal to 2.5 Armstrong. If you substitute that 2.5 into 10 to the power of minus 10 whole square, so then which is equal to, you will get 16.73 into 10 to the power of 3 electron volt. 10 to the power of 19. So we will get this 1.6 into 10 to the power of 19 per meter square. So option A is correct. And this is question number 30. The powder diffraction pattern recorded from a face-centered cubic simple using X-ray. The first peak appear at 30 degree. The second peak will appear at what? So we know that for this the Bragg's equation, n lambda is equal to 2d sine theta. Okay, and here consider second peak, order is 2, so here n is equal to 1. Next lambda is equal to 2d sine theta and lambda is equal to 2d sine 30 degree. They are given in the question. And for a first peak we know that d is equal to a divided by root of h square plus k square plus l square mod. So which is equal to a divided by, for a first peak it is 100 prime. So Miller indices, it is 100 prime for first peak. So 1 square plus 0 plus 0. So d is equal to a divided by root 1. And so therefore d is equal to a. D is equal to a and lambda is equal to 2d sine 30 degrees. They are given that this is for FCC, it is 1 square plus 1 square plus 1 square. So d is equal to a by root 3, and here lambda is equal to 2d sine 30 degree means 1 by 2 to cancel, d is equal to lambda. And for a second peak, the Miller index is 200 and first peak it is 111. And so therefore here we have an expression again that lambda is equal to 2d sine theta. Okay, and we know that lambda, if d is equal to a by root 3, d is also equal to lambda. So therefore you can write from this equation a is equal to root 3 into lambda, because d is equal to lambda here. So therefore here we will get lambda is equal to 2 into d for a second peak. So d is equal to a by root l square plus h square plus k square. So 2 square means 4. You will get a by root 4 into sine theta. So this theta we have to calculate, and therefore 2 root 4 cancel and Sin theta is equal to lambda by a, and theta is equal to sin inverse of lambda by a, means we know that root 3 lambda, okay. So lambda lambda cancel, remaining is theta is equal to sin inverse of 1 by root 3. So theta is equal to sin inverse of 1 by root 3 means 35 point something. So they are given that 35.3. So this is the correct answer. So option D is correct. Option D. Question number 32. The Charles phase of an element follows van der Waals bonding with the interatomic potential V of R is equal to minus P by root P by R power 6 plus Q by R power 12, where P and Q are constants. The bond length can express it as. So from the given, we can easily solve this. So that is, they are given V of R is equal to minus P by R power 6 plus Q by R power 12. So P by R power 6 is equal to Q by R power 12. Just tick Q by P is equal to R power 12 by R power 6. Okay, so then Q by P is equal to, if we solve this, we'll get R power 6, and if we send this, R power is equal to Q by P into whole power 6, whole power 1 by 6. Just a simplification, we will get option B is correct. So this is question number 31. The kinetic energy of a free electron at a corner of the first brilliant zone of a two-dimensional square lattice is larger than that of an electron at the midpoint of a side, the zone by factor B. The value of B is. So in these four options, option B is correct. How? So we have an expression that EK is equal to, at the corner H cross divided by M into Kx square plus Ky square. If we solve this, we will get H cross square pi square divided by B square M, because, and also kinetic energy at corner is equal to B into kinetic energy at center. So which is equal to H cross square pi square divided by B square M is equal to B into, at the center, if you solve, we'll get H cross squared pi square divided by 2B square M. 2B square M. So to make equation balanced, just multiply 2 in the numerator and denominator. Then these both sides are equal. So cancel this, and B is equal to 2. So option B is correct. Next, question number 33. The Fermi energies of two metal X and Y are 5 electron volt and 7 electron volt, and their d by temperature are at 170 Kelvin and 340 Kelvin respectively. The molar specific heat of these metals at constant volume at low temperature can be written as. So these are the options. This is the question, and these are the options they are given, and this is also very easy solution. You just use the calculation mind. So from this, if you want to calculate from the options, from these options, if you want to get this answer by using the question and formula they are given. So CV of X, they are given 5 electron volt. Substitute 5 electron volt, which is equal to gamma x t plus ax t cube. And for CV, it is 7 electron volt, which is equal to gamma y of t plus ax t cube. Separately equate these two equations and we'll get gamma x of t is equal to 5 and gamma y of t is equal to 7. So we'll get the difference in the given options, gamma x, gamma y, then the form of gamma x and gamma y. So if you solve this, gamma x divided by gamma y, then tt cancel, it is 5 by 7. And for this, if you compare second one, if you compare the second one question, so you have to get ax and ay coefficient, right? So let us take ax and ay. For this, if you want to calculate that, ax t cube plus gamma x t is equal to 0, just like for simplification, ay t cube plus gamma y t is equal to 0 and ax t cube is equal to gamma x t and ay t cube is equal to gamma y t. You have to calculate ax ay ratio and therefore you just substitute that ax just for you can take this ratio as 1, then ax divided by ay is equal to, here if you send this 1, so it is tx cube and this is ty cube, and ax divided by ay is equal to ty cube means it is 340 divided by tx cube means 170 whole cube, 0 0 cancel, 17 3s are, so 17 2s are, and 2 cube is 8, so it is 8. So option D is correct.